So this is the conclusion to section 631 in Griffith's Introduction to Electrodynamics, the bit after example 2. And you can kind of see the example 2 sticking out there in the corner of the window there. So the discussion here is that in the laboratory, you're probably not going to hear anybody talk about the D field from electrostatics. The reason why is when you're measuring, the stuff that you measure in electrostatics is the potential. And when you're calculating the potential, that gives you the electric field that actually exists between the two plates or whatever it is you're measuring. Whereas when you're calculating for magnetism, the thing that you're given is the free current that's flowing around. That's the thing you can measure. And when you measure that, that gives you H. Okay? So oftentimes inside the laboratory, you might hear people refer to the auxiliary field H as the magnetic field, which, you know, technically isn't correct. Some books, and this has a lot to do with the history of electromagnetism. Some books will refer to the H field as the magnetic field and talk about the B field as, you know, something like flux density or something like that. But anyway, don't get confused. The H field is useful in the laboratory, but it's not the fundamental quantity. It's not the thing that is the basis for everything else that's happening. And to try to derive electromagnetism, to try to derive the magnetic laws and stuff from H is really working backwards. So it's very confusing and it's very difficult. So anyway, let's just call it H, the auxiliary field H. Let's just say when we have the current inside matter, and we can measure the current, and we can calculate what H is going to be. We don't know what B is going to be unless we know exactly what's happening with the material on the inside. So anyway, that covers it, and that's basically what you need to keep in mind so you don't get confused. Thanks for your time. Bye.